Okay, so let us see this question also. A boy throws a ball vertically upwards from a 7-meter high roof. So this is the 7-meter high roof. If after 2 seconds he catches the ball on its way down again, with what speed was it thrown? So this is a question, with what speed? Now here what we are assuming, don't put in a lot of thinking. We are assuming that now this boy is just throwing the ball at that height, the height of this roof. Don't put in what the size of the height of the boy, no. We are assuming that now at this point, at the 7-meter high roof, a ball is being thrown like this. When it reaches there, of course it will have fall down like that. Now, we are starting. So, this is 7-meter high. They are asking us after 2 seconds. So, they are giving us that after 2 seconds, it means that this boy is catching the ball. After 2 seconds, the ball, he catches the ball on its way down again. So, because he was here, it means that he's going to catch this ball at that height. Because when I throw a ball, then I have to receive it. If I throw it at this way, I have to receive it. So, we are assuming now it's the same. So, to catch it at this point, at this point, our S is going to be 0. It would have covered 0 distance. Because it's still at the same point, remember, it started from here. So if it comes there, at this point here, so here, our S is going to be 0. And now remember, at this point when it's going upwards, so first of all, I tell you that the time after that is 2 seconds. It's catching it at 2 seconds. And now, remember, this ball is going upwards first. So meaning there, what it's going to do is going to be our acceleration is going to be negative g. Because it's going upwards. Okay. So what is with what speed was it thrown? So they are asking for the initial velocity. They are asking for the initial velocity. So you see all we have all these ones. So which formula are you going to use? Which equation are you going to use? Combining these ones. You see that? The stable formula for part A is S equaling to UT plus a half AT squared. Okay, so our S you see it's 0 at the time when this man is catching, this boy is catching the ball, it's going to be at 0 distance because we assume that it's catching that at the same distance. So meaning here, it will be at 0 distance because it will have moved when they come back. The distance there will be 0 from the point where it started. Okay. So if the example is very easy here. If I throw it there and then it comes back, so the distance moving upwards and then coming downwards, so they will be at the same. So the distance will be 0. That's why we have this as 0. So I have 0 equaling to u, which I write. Then 2, the time n minus a half because this acceleration is negative. So 9.8, then 2 squared. Okay, so this will be now 0 equaling to 2u minus, this one is going to be 4.9 into 4. Taking it this side, instead I have 9 2u equaling to, when you multiply there, 4.9 times 4, it's going to be 19.6. Divided by 2, our will be 9.8 meters per second. So, this is the velocity, the speed at which the ball was thrown. So, it was thrown at a speed 9.8 meters per second. As simple as that. Okay, then again, that's that. What is the velocity of the ball when it's being caught? So, at the velocity of the ball, so now, I will say here when it's being caught, is that the distance we are going to consider at 0 distance because it's catching at this point. So the velocity what formula we are going to use is that we need the final velocity, we have the initial, we have the acceleration, we have the time. But now is that this velocity is going to be negative because this ball is falling. So this is going to be a negative acceleration because our ball is just falling. So now we have from RB equaling to U plus 80. Now, you see, this final verse, it's falling. So it's going to be now negative because it's falling. So this is negative equal to our u, which is 9.8 then minus 9.8 into 2. So this will be negative b equaling 2 when we get that. I think you see we are going to get 9.8, then minus 19.6. So that our final result is going to be 9.8 meters per second. So this is the result which this man is getting about there. Now we need to also now in part C is that if the boy misses the ball, so maybe when he's catching the ball he misses it. Now they're asking us at this. Let me get another character. Okay, I think people will be able to see now. After there, now this boy is missing that ball. Then, after missing, of course, it will come and then to be hitting the ground. Now they're asking us if the boy misses the ball, with what speed does it hit the ground? Now, here, at this time, you start from here. When I look from here, you start here, the distance now is going to be negative down from 0. So from here up to here, this distance, we are going to take it as negative because it's below the initial point. Whenever the distance you want is below, this was the initial point, so this distance is below the initial point. So it's going to be negative 7 because it's below. The point is now covered in the negative distance because if this was the starting point, then below it is going to be negative. So that's why here, our S is going to be negative 7. Here, from here up to here, it's going to be negative S. Then, they're asking us for the velocity, the final velocity which we don't know, but it's going to be negative because it's going down. And then what else do we have? The distance is going to cover is that. So, we have the distance, we have the initial velocity, so we can use the third equation of motion. In our part C, we know that RV squared is equal to U squared plus 2AS. As simple as that. Now, you can't use the first because we don't have the distance. The formula, and we don't have the distance in the first. That's why you have to use the third. So we need this, but remember it's going to be negative now, but because we are squaring it. Why negative? Because it's that it's going in negative direction. The positive, then the negative. That's why this one always our whenever the ball is falling, it's going to be negative. Squared equal into our U, we got our U as 9.8 squared. Then minus, because we said the moment the ball is going upwards fast, always our acceleration is going to be negative. 2 into 9.8. Then times our S which is negative 7. As simple as that. Okay, so what do we have here? We have RV squared equal to 9.8. This is 96.04. Then minus this minus and this minus is going to give us a minus and a minus. It's going to give us a positive. So we have 14 times 9.8, which is 137.2. And so our V squared here, we shall get 3.24, and our V get a square root of both sides. We get 15.27 2 meters per second. Now, this is the velocity at which, after this way missing it, it's going to hit the ground. Always, whenever we have the ball going upwards, fast, vertically upwards, without our acceleration is going to be negative d because we are opposing that gravitational force. That's what we are going to consider already. So, that's it. Members, don't assume here, now after here, the acceleration is positive. No. As long as at the first flow it was going up, clear, it's going to be negative. Good. So that's how we handle that issue well.